So today's topic of discussion is bioprocessing. Then advantages of bioprocessing methods, then historical developments of bioprocessing, criteria in the choice of organism, then what type of media is required during the bioprocessing processes, then what is upstream processing and downstream processing. So you people have already studied about the fermentation processes, and you have idea in different dairy technology courses about manufacturing of different fermented dairy products. So why we are using a typical type of or a particular type of starter bacteria, what will be the end product of using that particular culture, or what type of condition you have to maintain during the whole manufacturing operation. Depending upon that, you have to formulate a particular type of raw material, or sometimes you are adding something, or sometimes you are removing something from a particular product. And after getting or after giving propagation technique, utilizing propagation technique, you add some amount of starter bacteria for continuation of that bioprocessing or fermentation process. So what is happening in that? You can say it is a process in which a substance breaks down into a simpler compound, and just by the action of different type of microorganisms. So your main aim is to produce certain product having some kind of beneficial uses. So if you talk in biochemical way, so you can say that it relates to the generation of energy by the catabolism of organic components by the action of different microorganisms. So today we will discuss in detail about the bioprocessing methods. So it is generally used of different kind of biological materials like organisms, cells, organelles, enzymes, to carry out a process for commercial, medicinal, or scientific regions. So different type of microorganisms, as all of you know, that is the main thing, that is the heart of any sort of bioprocessing method. So just by utilizing those organisms, you can create a particular type of processing inside a chamber, inside a vessel, and just by doing that, you can produce a typical type of end product. It is this process, if you talk about the bioprocessing, it is generally used in the production of pharmaceuticals, foods, flavors, fuels, and chemicals with the help of biocatalysts such as enzyme, microorganisms, plant cells, animal cells in a bioreactor. So you know about fermentation. So what additionally we work is going inside that vessel. Sometimes you are adding some kind of enzyme or a combination of enzyme. Sometimes you are adding some plant cell or animal cell for achieving certain type of fermentation inside the bioreactor. It also involves genetic engineering for manipulation of plant, animals, and microorganisms such as yeast, bacteria, fungi. We are using these microorganisms, especially yeast, bacteria, and fungi, depending upon the nature of your final product, what type of product you are going to manufacture. Depending upon that, you have to select a particular type of microorganism. So bioprocess operation should ideally manufacture new products and destroy harmful waste. So why we are using this bioprocessing? We have to produce certain newer kind of product like antibiotic, therapeutic proteins, vaccines, hormones. Automatically, for manufacturing these items, you have to go for this particular process, or you can say you have to use this particular bioprocess operation. So bioprocess have been developed for a number of commercial products. relatively cheap materials. Previously, we were using this process for manufacturing cheap materials like industrial alcohol, organic solvent, which you are using in your laboratory. But nowadays, people have started using this particular process for manufacturing a very valuable items, or you can say very expensive specific chemicals such as antibiotics, then some kind of therapeutic proteins, vaccines, etc. Now, what are the advantages of bioprocessing? You can handle it in mild condition. You can, at the same time, you can save energy. It is very specific in their action because you are selecting a particular type of a substrate. And at the same time, you are selecting a particular type of microorganism for achieving a certain type of changes or a particular type of product in after that fermentation process. And it is very efficient process, and it is also biodegradable in nature, safer. So these are the advantages whenever you are selecting a particular type of bioprocessing method. What is happening in that? In fermenter, you are taking some kind of substrate, and thereafter certain period or certain incubation period, after inoculation of a particular type of microorganism, whole fermentation process will take place. Thereafter, you have to harvest your cell, or cell after purification, you can get a purified cell product. And in some cases, supernatant will be extracted or taken out. Thereafter, purification process will be done. And it has been observed that there are two types of product formed during the bioprocessing. In one case, intracellular products are formed, and in another case, extracellular products are formed during the fermentation process. So the extraction, separation, or purification process for both is different, and you have to choose different methods in both the cases. So something about the modern biotechnology, what is happening and how it is affecting the bioprocessing process. So modern biotechnology tools such as recombinant DNA, gene probes, cell fusion, and tissue culture offer ways to produce new product or improve bioprocessing methods. So modern biotechnology has allowed us to produce sophisticated medicines, cultured human tissues and organs, biochips for new age computers, then environmental friendly compatible pesticide and powerful pollution degrading microbes. So a number of different type of work people have started doing with the help of these bioprocessing methods. So with the rapid development in food science and technology, people have started using the recent advancement in case of whatever advancement is there in case of DNA technology, different kind of biotechnological tools people have started using in dairy and food sector. Now something about the historical development of bioprocessing. You can go through this table and have idea about the wine making process. Then beer developed in Egypt, Babylon in 5000 to 7000 BC. Then yeast use was started in the 2000 BC. Vinegar in 0 to 500 BC. Fermentation word is mainly derived from the Latin word that is fermentum, and it was used for yeast, and the meaning of chemical change accompanied by effervescence. So in the 1600, this fermentation word was introduced in the world. So in 1680, Van Leeuwenhoek was the man who observed yeast cells in fermented beer. Then Baker's yeast produced by Dutch process was introduced in the year 1781. Pasteur, one of the well-known scientists in the field of microbiology, he established a relationship between microorganisms and infectious diseases in 1877. In 1888, Koch developed technique for the handling and maintenance of pure culture of organisms. So these are the different scientists who are directly, indirectly related for the improvement or some kind of development processes in the field of bioprocessing. Now, the development of genetic engineering and monoclonal antibody technique, which started in the year 1970, this has led to the introduction of large number of new products with application of many different areas. So recently, you must have heard about the monoclonal antibody technique for uh, development of different type of vaccine for controlling this COVID-19. So it's a very recent technique, and every day a newer type of development you can observe in different part of the world. So most highly visible application have been in the area of human healthcare with products such as human insulin, interferons, tissue plasminogen activator, erythropoietin, then colony stimulating factors, monoclonal antibody based products. So a number of different type of things are there where people have started utilizing just this genetic engineering process and started getting benefit of this particular bioprocessing tools. So if you talk about new products in agriculture or food industry or fine chemicals and the environmental protection, everywhere you can see the use of different type of bioprocess methods. So you can say a bioprocess is a specific process that uses complete living cells or their components, that is bacteria, enzymes, chloroplast, to obtain desired products. So what are those desired products? And how you can produce these things? What are the different processes? What type of microorganism is required? What type of substrate is required? Automatically, we will discuss about all these things in our next slides. So types of end products of fermentation include microbial cells, that is bacteria, is fungal spores. Then we are also producing some microbial enzymes like milk clotting enzymes or renets. You have idea about microbial renets? Then you can also use for production of recombinant fungal and bacterial renets for cheese manufacture. There are a number of different microbial metabolites like alcohol, ethanol, butanol, then 2,3-butanediol, isopropanol. These are the different microbial metabolites which you can produce by this bioprocessing method. Then some chemicals like lactate, propionate, then proteins, vitamins, antibiotics, fuels. These can also be produced by different bioprocess methods. And a very important and most recent recombinant product is hormones, which are used in different medicine that you can also produce by using different type of bioprocessing methods. So if you talk about the different kind of industrial product, it is generally divided in two groups: anabolic products as well as catabolic products. So under anabolic products, enzymes, amino acid, vitamins, polysaccharides, yeast cell, single cell protein, nucleic acid, citric acid. So these are the products produced by anabolic reaction inside the vessel. Then catabolic products are ethanol or ethanol containing products like wines, butanols, acetone, lactic acid, and acetic acid, that is also called vinegar. So all these products can be produced by utilizing this bioprocessing method. So here in this table, I have given some examples of industrial products of microbial secondary metabolism. So just by going through this, that what are the product, what type of microorganism involved for producing a particular type of product, and where that product can be utilized. And one thing I just want to tell you people, that a very specific type of microorganism having a specific character is generally selected and generally used for manufacturing of a particular type of product. So compatibility is very important with substrate, what you are using or what you have selected for uh, giving fermentation process or starting fermentation process for producing a particular type of end product. So now it is very important to know the criteria for selecting a particular type of microorganism. You have already studied so many things, so many desired characteristic in a starter culture course. So here I just want to summarize you the important criteria in which is highly required for selecting a particular type of organism. So first of all, nutritional characteristic of organism, optimum temperature of the organism, then the reaction of the organism with the equipment of the which you have used, and the suitability of the organism to the type of process to be used. Then stability of the organism and its amenability to genetic manipulation. So whatever character is there, the microorganism must maintain that character during the fermentation process. Nutritional requirement, optimum, what is the temperature, optimum growth temperature of that particular. These all are very important to know before selecting. Now the next one is the productivity of the organism measured in its ability to convert substrate into product and to give a high yield of the product per unit time. So it is also very important whenever you are selecting a microorganism. The ease of product recovery from the culture. Sometimes what is happening? Intracellular end product is formed. In some cases, extracellular product is formed. So automatically, you have to select that particular type of microorganism from where you can easily recover that end product. Then irrespective of the origins of the industrial microorganism. So it is also very important during selecting a particular type of microbe. Sometimes what we are doing, what we have to do, sometimes whatever existing microbe are there, we have to improve it by utilizing certain biochemical, biotechnological tools. So strain improvement is also very important, regulating the activity of the enzymes secreted by the organism. So just by adding some compound or just by restricting or adding some kind of growth factor, you can perform this thing inside the vessel or inside the bioprocessing chamber, then increasing the permeability of the organism so that the microbial product formed that can taken out from inside microbial cell. Thereafter, selecting suitable producing a strain from a natural population. What is recent trend? I just want to tell one thing to you people, that recently people have started selecting those strains which are naturally present. They have, different scientists have started uh, isolating it from the natural things. So just because of its acceptability, just because of its stability and giving good performance during the fermentation process, people started choosing this kind of starter bacteria or strains for performing a typical type of fermentation process. Then manipulation of existing genetic apparatus in the producing organism. Thereafter, introducing new genetic properties into the organism by recombinant DNA and technology of genetic engineering. So these things are very important for improving a strain which you are going to use for achieving certain type of bioprocess method. Now, how you can manipulate things? So manipulation of the genome of industrial organisms in strain improvement is done by mainly of two ways. Method not involving foreign DNA. So it is conventional mutation method. You have already heard about this and have some idea about whenever a particular microorganism is there in the system and you are creating certain negative environment for that microorganism, there may be chances of mutation, and automatically is a very important thing whenever you are considering any sort of bioprocessing method. Now, methods involving DNA foreign to the organism. So recombination nowadays is very popular for improving a particular type of microorganism, and This can be performed by choosing transduction method, conjugation method, transformation method, heterokaryosis method, protoplast fusion. Then genetic engineering is one of the well-known method, metabolic engineering, site direction mutation. So but just by utilizing these methods, you can improve the uh, character of starter bacteria or the industrial organism which you are selecting for a particular type of bioprocessing method. So you have already selected your strain. Now it is very important to know something about the substrate which you are going to select for that particular uh, microbial culture, because if there is if you maintain that level of compatibility, automatically whatever desired product you want to produce, that can be produced in the system. So what are the main things? Cost of the material is one of the main considering point. It should be cheaper, automatically easily available in the system, readily available in the of the raw material is very important thing. So wherever you are performing these things, the availability of these materials should be assured. Then transportation, minimum transport cost. Suppose you are installing that kind of plant here in Bihar and you have to procure the raw material from Karnataka or Tamil Nadu, automatically the transportation cost will be more and the overall manufacturing cost will be increased, and your industry will be not in profitable condition. So automatically you should know about the substrate, from where you are getting, what type of substrate is there, what is the quality of that substrate, and where it is available. Now the ease of disposal of waste resulting from the raw material. Nowadays, a number of different kind of rules and regulation are imposed by different bodies like pollution control board, or there are some boiler inspectors are there. Whenever you are going to dispose your waste material, automatically you have to get certificate from those authorities. So one must have to follow the guidelines given by those authorities. So that is very important whenever you are going to start a particular unit in your area, especially for bioprocessing. Now the uniformity in the quality of raw material and ease of standardization. It is also very important. The quality of the raw material in terms of its composition must be reasonably constant in order to ensure uniformity, because you all are dairy professionals and you have idea about the uniformity. Every day when you are joining any industry, in that you have to maintain and you have to produce a uniform quality product in your daily routine. Otherwise, you just can't maintain your reputation in your uh, state market or country market. So uniformity is one of the very important point, and how you can maintain, just by getting a same type of raw material you can product, or you can maintain uniformity in the final product. Now adequate chemical composition, whatever things required in your substrate, that must be present in the system. Sometimes you have to formulate, sometimes you have to use some carbon sources, nitrogen sources, mineral and vitamins for making appropriate composition of that substrate. So whatever substrate quality is required for performing a particular task or for producing a particular end product, you have to choose adequate material having required chemical composition. Now, presence of relevant precursor. So whatever precursor is required in the system, you have to either extend, add from outside, or it should be there in the substrate. Now, satisfaction of growth and production requirement of the microorganism. Many industrial organisms have two phases of growth in batch cultivation. So automatically you have idea about its growth behavior, how much time it will take during lag phase, then how longer is log phase, what type of nutrient you have to add in the system, at what or in different phase you have requirement of different microbe is different. Automatically you must have complete idea about those microbes as well as the behavior of substrate you are using. Now the components of media for industrial inoculum development. You already have idea about uh, different type of substances you are using for preparing a particular type of media. Carbon and energy source, nitrogen source, nutrient product, carbon dioxide, then water, heat, biomass. So these are the requirements for making a particular type of substrate which is required for achieving or for uh, utilizing in your bioprocessing vessel. Carbon sources are given here, fat and oils you can use. Then nitrogen sources are also mentioned here. In addition to these three major components, water, minerals, vitamins, growth factors, precursor, inducer, and elicitors, then inhibitors, cell permeability, modifiers, oxygen, anti-foaming agents. So these things are required whenever you are formulating a particular type of substrate for achieving or for producing a certain type of end product. Now something about the upstream and downstream process. What is there special in upstream process? It includes selection of microbial strain characterized by the ability to synthesize a specific product having a desired commercial value. And these selected strains are subjected to improvement protocols of to maximize the ability of the strain to synthesize economical amount of the product. So first of all, it is you should have idea about the upstream, what is upstream and what is downstream processing. So what are the things you have to include under upstream processing, and what are the things you have to include under downstream processing? So what are the things generally included under this? So just I am going through this slide. Including in the upstream phase is the fermentation process itself, which usually is carried out in large tanks known as fermenter and bioreactor. Whatever tank you are using, it is also known as fermenter. In addition to mechanical parts, whatever devices, you can say different type of accessories or mountings are there fitted on the that particular bioreactors. So you have idea about that. Some kind of aeration, some kind of devices is there for creating aeration. Then for cooling, there are some circulation system is there. Then for agitation, some device is there. The tank is usually also equipped with complex set of monitor and control devices in order to run the microbial growth and product synthesis under optimum condition. So this whole thing where you are using some kind of substrate, you are using a specific type of a strain. So these all process is known as upstream process. And what is downstream process? After fermentation, whatever product will be formed, so you have to recover your end product. So for recovering, you have to follow some steps like extraction, purification, or characterization of the desired product. These all are considered as downstream processing. A vast array of methods for downstream processing, such as centrifugation, filtration, and chromatography technique, which you are using for purifying process, it all comes under this downstream processing. These methods vary according to the chemical and physical natures as well as the desired grade of final product. Here in this figure, you can have idea about the outline of fermentative process. This is upstream process, and after fermentation process, product will go for purification process. Product will be formed. Then whatever effluent is there, that will be utilized as per the nature and characteristic. So these are known as downstream processing. Here in this method, I have also tried to give you the complete information about the bioprocessing. First of all, medium preparation is very important. Sterilization method will be given to the product for getting a sterilized substrate. At the same time, culture propagation will be done as per the requirement of fermenter, or as per the requirement of whole lot. Whatever temperature you have to maintain, whatever pressure or whatever strain you have to use just by adding, and just after uh, cultivating that particular microbe inside that chamber, a certain time, you have to break the whole process. Thereafter, you have to go for extraction process by just by using centrifugation method or some other method. So, utilizing different ultrafiltration chromatographic technique or precipitation technique, you can purify those end products, and thereafter packaging will be done as per the nature and quality and the characteristic of that end product. So what is there in downstream processing? The various stages of processing that occur after the completion of the fermentation or bioconversion state, including separation, purification, and packaging of the product. It is all included under downstream processing, removal of insolubles, product isolation, product purification, product policing. So all these things are very important whenever you are going for producing a particular type of fermented product. So a very few recovery methods may be considered to combine two or more stages. For example, expanded bed absorption and complete removal of insoluble and product isolation in a single step. And if you use affinity chromatography, it often isolate and purify in a single step. So this is all about the bioprocessing method, and you have to produce a number of different type of fermented product. So automatically, just by using these method, you can produce those kind of end product. So I think this is all about your bioprocessing.